Okay, so let me introduce Katie. She is a tutor from California, as far as I understand. Yes.
Mhm. Yes, correct.
Yeah, and it's interesting to hear their opposites side of a story. We usually talk about we usually look at Russian kids or uh, that study in some Russian school abroad, yeah, and you look at Russian kids or other Russian speaking people that come to American schools, yeah, and they have some problems, yeah. So it's interesting to hear about that.
Yes. All right. So I would like to start with showing you the very real test of a Russian boy who is, I think it's around 8 months. He's in the American school at the moment. His English is very good. He doesn't have issues with English at all, but he's struggling with mathematics. Um, as his mom informed the school and me, she said he never had any issues and he had a good understanding of math. He had good marks. He is from Moscow. He was in one of the very good schools. So he is actually very frustrated with the situation that he cannot do well. He doesn't seem to be able to do well. So, and I would like to go over his test. He is in grade 4. So that is basically primary school. And his main problems, well, just are very typical problems for the Russian kids who come to English classroom, American classroom. And let's have a look what actually is difficult. So basically, he does have a very good understanding of how to calculate. He is aware of algorithms. He doesn't have an issue, but he has zero understanding of what he is looking for and how to interpret what he did. So here is a very typical problem. The harbor master decides how many trips the ferry needs to make for 37 cars. The ferry can carry 8 cars at a time. What is the best way to interpret the remainder of 37 divided by 8 so that all cars can cross the harbor? So he's got the remainder. He's got the remainder equals 5, and he is explaining. So 5 cars can cross the harbor. I talked to him. I asked him, "Can you please explain to me what do you mean?" He says, "Oh, actually, I don't mean anything. I just needed to write something because I have no idea what does the remainder mean." So, and yes, he knows how to solve the problem. He knows how to divide, so that is no problem at all. But unfortunately, the understanding is completely lacking. What is behind it? Now, the next one is very similar. Kennel is moving 160 dogs to a new facility. Each dog has its own crate. The facility manager runs 17 trucks. Each truck holds 9 dogs in their crates. Write a division problem that can be used to find the number of trucks needed to carry the dog in their crates. And then what does the remainder mean in the context of the problem? And he said that the remainder means that 7 dogs that move in a new place. So again, why did you write that? No idea. No idea what does it mean. I have no idea what does the remainder show us. So that is very typical. That is very typical in American school from grade 1, from kindergarten. We make the children explain what it is. A lot of word problems, and basically they need to know exactly what is happening. So to solve this sum doesn't mean anything. You don't get any marks, so you get minimum marks. But interpretation, it's very important. And that goes from the primary school up to AP subjects. So when children take AP statistics, AP calculus, a huge part of the exam is interpretation of what actually we found. Why did we do that? Real life math. So and what? So this question and what is very important. And it doesn't seem that a lot of children coming from Russian school are ready for that. They seem to be very happy to follow the algorithm, to follow the rules, and that's it. They don't ask the question, and what does that mean? So I've sorted it. That's good. I've got the answer, and the answer is right. So, the one of the most important problems which our children have also when they move it is solving the equations. So when we introduce equations in grade 2, normally, some very advanced children are getting that in grade 1. So we start with the balance scale. And this kind of problems, we deal with them for a while. So there is no actually really an algorithm how to solve the equation. Everything is about reasoning, understanding what is happening. So there is no that, like the Russian textbooks, I believe, show that. 1 second. Think was it seems to be quite similar, right? So it's almost the same, but in the end, it actually says there is a rule. So you do all this work, and then there is a rule. And what we find that a lot of children just know the rules. They don't remember the reasoning behind it. They do know the algorithm, but this is an algorithm for the simplest question, so for the simplest problem. And if the problem deviates a little bit, then they are completely lost. The way we deal with our equations, we are trying to use the principles, the addition principle, the principle basically of the balance scales. So if you take something off one side, you have to take something off the other side to keep the balance. What do you need to keep the balance? That's the question we ask our children all the time. And that helps them to solve equations up to calculus. So they know that what you do on the one side, you do to the other side. You keep the balance. And you isolate. So you isolate your weights and you keep the balance. So I find it's much deeper understanding and obviously much deeper interpretation as well. So what we do, here are examples how we do it. So we want to find out what 5x equals, so we need to get rid of the plus 3. That's why we add minus 3 to each side, right? So that is the principle which actually helps children to solve any kind of equation. They do not need to identify what are they looking for. They do not need to think, which rule am I using? That's the principle. That's the difference between the principle and the rule. And this whole situation with the rules, I found that Russian children, they come and they have very good knowledge of the rules. So yes, they've done a lot of equations. They've done a lot of rules. They know all the rules. But if there is a small deviation, they're completely lost. They don't know what to do. They don't know how to do it. And if you present them with something like that, that's already a huge issue for most of them. Apparently, they are supposed to do it later in the Russian school. But if you introduce the equations from the point of view of principles, then that doesn't matter what you do. You can solve anything as long as you know multiplication, division, and addition and subtraction. For the primary school, you can do anything. And then obviously for the middle school, that's already raising into the power and taking a root. And then differential equations already in the high school. So that is one huge issue, which is very confusing for a lot of children. Now, something like that, these kind of problems, which are also introduced for quite small children, a lot of the children are very confused with that. They don't know what to do. They say, but what is the circle and what is the triangle and what is the square? We don't know that. We don't understand that, and all these kind of things. So the idea of the imaginary operations, so the operations which don't exist, or imaginary variables, which obviously are not necessarily letters, but can be anything. It doesn't matter what you're counting. So that is a very important concept, which also has to be done. Then the big issue is division. Division, of course, it's really a struggle. And especially the struggle for those kids who they know how to divide again, but they cannot interpret what are they getting. So the big when we introduce division, we introduce it that way. That is division with a partial quotient. So basically, what we do, we show that it's one step before long division. Then we show what we exactly were getting, and then we are adding all the digits there, all the numbers, so we are getting the answer. So that is the way it's introduced, and that gives quite a bit of grounding in terms of how division actually works. So that we divide actually 8,000, then we divide 200, then we divide 30, then we divide 6, and then we get our remainder. So, that is also very, very difficult for the children who are coming from Russian school. They say, well, that we don't need to do it. We do understand it how. But again, there is knowledge of the process. They do know the algorithm. They can divide, but they cannot interpret. And they really struggle with even simple problems, which we found very funny, doing a mental math, because I thought always that, and actually it was a case before, that the mental math was a big thing in Russian schools. And I know that you guys are not allowing calculators till the end of school, and exams and tests all are done on the paper. But nevertheless, I found that there is a very little understanding of what is happening behind it. Obviously, another very important part, which is problematic and the children are struggling with, is the whole section of statistics. And I believe that there is no statistics in the primary school practically in Russia. So the children in American schools, they deal with statistics from the kindergarten. They do the tallies and they analyze the data. So again, the most important part is to analyze what you've received, all the information, all the data you represent on the graphs, and there is a lot of work done in that aspect. So then obviously the high levels of statistics, that's already coming much later, and the children are enjoying it. But one second. That's basically what we do with grade 1 children. We take surveys, we ask questions, we do tally marks, we get data, and we actually represent our data in different ways. So one way, there is another way, there are different options, and here again, one way and another way, we think which way is better. And of course, the analysis, which breakfast food is the least favorite, which breakfast food is the most favorite, how many more students choose cereal than toast. If 5 more students chose eggs, how many students would have been surveyed? So all these kind of problems, they're very real, very real life problems. They're done in their classroom, and or they're done at home sometimes as a project. And children know a lot about collection of data and data analysis. They can read graphs, which is important to know how to do it. So obviously, the kids who go further with mathematics and they do AP statistics, they go in a very different way. So there is a lot more there. And again, it's mostly explanations. Why? What does this data show? How? Why do you know that this data shows that? Is it reliable data? Is it not reliable data? So that's a very important questions which they discuss from the primary school and up to AP statistics. Obviously, the methods are much more complicated, but the idea is there. So they're getting used to the fact that that's what we do. We discuss, we check whether the data is reliable, and we decide based on what we know. So the statistics is a big thing. Then there is obviously a the probability theory. Probability we also introduce in grade 1, sometimes even in kindergarten with the experiments with coins and coin tosses. We do tallies, so we look into statistics and probability together. So they do the experiments, they toss the coin, they do the tally, they figure out what is happening. And this probability, the idea of probability is very important. So by grade 3, they have relatively good idea of Pascal's triangle, of the probability, and what is happening in this aspect. And obviously, further on, the children take courses. Probability is a part of the AP statistics for high school. So those children who are really serious about their math, they take normally AP statistics, and they have this section on probability. But what we found also that the Russian children, they don't know anything about probability. And until they actually, if it's a primary school. So they struggle with the whole concept. What does it mean? How does it work? And of course, it's difficult for them to catch up because it's a process for the child to get understanding and grounding in these ideas. So that's why we start so early, because these concepts are very easy to understand. For the little children, they're easy to understand. And for a grown-up, for an older child, it seems to be very challenging. So obviously, on the specific level, it's good to introduce these kind of things and these kind of concepts in a very real way, in a very experimental way, in a very quite early age. So that is probability and statistics. So another part which is for the high schoolers. High schoolers, obviously, they have much more challenges. And when they come, obviously, it's statistics again, it's probability, because the level of probability and statistics in high school is quite high. But also, either take pre-calculus, even in grade 7, we already face the fact that the children don't understand the polar coordinates. So they seem to know Cartesian coordinates, but they don't know polar coordinates. And they're struggling with the concept as well. So they ask, why do we need that? So, that is another issue which we always struggle with. Otherwise, the system is different, of course. The focus is different. the focus is not on actually training the child to sit for the exam, but more to train the child to understand and to move in their pace. Because we have different levels of courses offered practically on every level, starting from grade 4 already. We have honors and we have you can go ahead. Some of the children, they finish high school with 2 or 3 years of university math. So that is very real and it's possible. But also there are other children who actually choose to go and do financial math. So basically just to calculate their taxes, to know, but at least they have an understanding of that. So yes, there are different levels, and the idea is not to make everybody the same, but to make sure that the children understand what is happening and have deep understanding of the processes and deep understanding of the principles of the math which they apply. So what we found also that some children, some parents also struggle because they want the mark. And they want the mark and they want the highest mark in the highest possible top level, top set. And the question is, then so there is a child who says, but I don't want to do math ever. And we advise parents, well, maybe just choose another course, but the parents don't want to. And this poor child is just going and he is struggling and he is struggling and he is failing. And it's difficult. And then he scrapes his head, and then it does actually, it doesn't help when they want to go to university because the low mark is not that great. The GPA is low, and it could have been much higher if they chose another course. But this concept, I think, is difficult to understand for a lot of parents coming from Russia. The freedom of choice of the subjects is a little bit complicated. So not really subjects, but more of the courses, the freedom of choice with the courses. And otherwise, what we found is the children obviously struggle. Sometimes they struggle with language, but that's understandable. So we cannot really help fast. There's no fast fix here. On the other side, the parents who paid attention and actually prepared for moving, they bring children who are very ready, who are really ready for school. And there are some children who just go into the classroom and they're happy there, but then we know that there are years of work still in Russia. And the parents really spend quite a bit of money and quite a bit of time on making sure that the child will be happy in the new classroom. So also, as the system itself, we have the obviously support for the Russian children, not for the Russian children, for any children who come into the American classroom. And there are teachers, there are extra teachers, there are extra teachers who teach extra teachers and who explain the situation. So there are online consultations. There is serious work which is done normally with parents, but it's all district dependent also. So there are certain districts which are really good at it, and for example, New York, California, and there are certain which, like, for example, Florida, where there is a minimal support. So a lot of parents realize it too late sometimes, and they could have chosen a different place to live, but it's a little bit too late. So as for the situation with the tutors, it's quite interesting because when the children come in, they always say, yes, but I had tutors for years. And it seems to me that there is almost like habit of getting tutors almost from grade 1 or grade 2. A lot of parents are very happy to get a tutor, even if the child is not behind, or we don't have this culture. The tutors in the US are exactly that. They tutor children who are behind mostly, or the children who are exceptionally ahead. But then again, if the child is able to go ahead, there are other options, and mostly they do classes in community college, they do classes at universities. So there are different hybrid options. So yes, that is a little bit strange that the parents actually want to have a tutor for the child who is not behind, but they're so used to it, the children, that they feel they need it. It's almost like, but I don't have a tutor at the moment, so what will I do? How will I do it? But you're okay, you should be all right. So very different ideas and very different principles. So yeah, that is basically what I wanted to say. It's in a nutshell the differences, and I'm very happy to answer your questions if you've got any.
Thank you for your presentation, Katie. Yeah, maybe some questions. Victoria?
Yes, I have many questions. Thank you, Katie, for this talk. It is very difficult for me because I have lost too many works in Russia when I lived in Russia because of these problems. And they said, the parents said to me, they had complaints. I don't know the word. They came to the director or administration and said that I'm an awful teacher, that there are rules and their children are very good and the teacher is very bad. So, yes, really, I'm not a usual teacher, not usual Russian teacher, because I thought about understanding, not about rules or marks, or to be first, or to be the same like the all, or what another people will say about my child if he will get awful marks and etc. etc. Yes, and I see it is a big problem. But in Russia, I was like a crazy person. And yes, and now I know, and now I can see the communities of Russian parents. I live in Mexico now, so on your continent, yes, and I can see what people say about math education in Mexico and in USA because we are living in the same time zone with you, and many children came to the schools of Mexico or of USA or Canada is the same. So I have many feelings now because it looks like it is all my life about it. I don't think that this. So I think, Katie, what do I think that you can? It is not about traditions of maybe math education. Maybe now you can feel it yourself the culture of Soviet Union. I think maybe not all people say think the same way, but I think this way because it is a way of living. It is I think, tragedy living. And I don't know. I had a question about parents, not about children, because the children, if you are working in primary school, so it looks like they are not teenagers. Teenagers can be. I'm working with teenagers, so when they are 12 or 13 years old, they can be rude. They can say you that you are a stupid teacher. You don't understand. You understand nothing about math, and their tutor and their parents are clever than you, so they can go to the administration of the school, etc., etc. Yes. So I think you need to communicate with parents because the children are very small. There's a first grade, second grade, yes. So it looks like they can't provide their own meaning of the situation. So I communicate with the parents. What do you feel about it? What is the difference? Do the parents understand the problem? Or maybe they don't try to understand this. Maybe they're, because I feel like the parents, they think they are clever. They know what they do. Like they are the teachers of math. I'm not a teacher of math. They know better what to do. They know
Yeah.
better mathematics. They know better all about this subject. So I feel like they are looking down at me, and I feel it when I left Russia 2 years ago, and I saw in the immigration communities. Uh, Looks like they are looking down the culture of mass education in another countries. Do you maybe feel the same or something else? Because what I see, they say the math is awful in the Mexican school, in the USA. We don't understand what they're doing. It's about statistics, it's about meaning, it's about solving the equations, yes, of course. Because they have another rules about another rules of counting, another rules of solving. We don't understand what the teachers want. They say that they are like stupid, and they are afraid that their children will like the level of their math education, and they are looking for the tutors, Russian-speaking tutors with Russian traditions of math education, and it looks like something. I think it is something wrong. Children need to understand the rules of another world. Like you left Russia, but Russia doesn't left your mind. Yes. So I feel that. I don't know. I'm interested in your experience with talking to Russian parents. Because firstly, it is like generations that of generations they think that they know math. They think that the math of Soviet Union was the best math in the world. Etc. in Russia, the same. But I don't think so, because the Soviet Union was closed. Yes, there is interesting history of Soviet mass education, but it was a period of 30 years Russian mathematics, not Soviet Union. But it looks like we have now the calculators, we have now phones with applications, with photomath, with GeoGebra, Desmos, etc. And it looks like Russian parents try to move children in the past, not to the future. They cancel statistics, probability, all these things because they don't know what about it. Like all the world goes step by step to the future. And it looks like Russian children with Russian parents, with Russian tutors and teachers are going to the past, to the Soviet Union. It's my opinion. My colleagues cannot be with me in this way. But what is your experience with Russian parents?
Well, you probably heard about the Russian School of Mathematics in America. Very popular with Russian parents. So yes, this whole idea that we need a Russian tutor, we need a Russian School of Mathematics, that the after school work, and we want our children to do math the way we did. So yes, it's theoretical. And look, there are children who might benefit from this extra work. And there are children who will benefit from the theoretical approach. But quite frankly, how many of our graduates will actually be doing theoretical math? Most of them, probably 95%, will need a completely different set of skills. And that is unfortunately what is not addressed and what is not even catered for in the Russian school of math. And I don't know, like in the Russia, I'm not so sure about that as well. So to me, it's very simple. The reasons are also, well, I don't know whether I'm right or not, but I believe that statistics gives a lot of freedom to analyze information, and the whole idea of being able to read and to analyze, it's not that cool in Russia, probably. So that's why it's not in the school curriculum. That's very dangerous to actually give these tools to a population that they will be able to analyze what is done and what is happening and understand from the mathematical point of view, forecasting and just even minimal forecasting and understanding of what is really happening in terms of inflation, what is really happening in terms of the currency rates and so on. So yeah, that's something. But a lot of parents, a lot of Russian parents, they still want their children to have this Russian way of understanding. And to me, when I talked to several, and they said, "But we don't know what's going to happen. Maybe we'll have to go back, and then what will we do?" I understand it. I can understand it. That's obviously a worry. And if you don't feel it's permanent, you want sort of to be ready for any scenario. But yes, we don't really work with parents that much. It's mostly the initiative of the parents, or some situations when the child is really needs support and is referred further. So like an average child, we do not work with the parents. Sometimes the parents initiate the contact and they ask questions and they tell us, but mostly the children tell me, "Okay, you know what? My Russian tutor said this and that." Like, okay, that's great. So yes, you're right about that they want to, but for different reasons. I'm not sure. Maybe some people because they're worried that they will have to go back one day. And I even heard from one family, yes, but my child can get university education in Russia for free, and here we'll have to pay a lot of money. Well, fair enough. Yes, that's a reason. That's a good enough reason. So yes, understandable.
And to clarify, so the typical way how you come into play, so some teachers, some students have problems in school, and you work with schools, yeah, so they tell you like this student has problems, and you come into the game, yeah.
Yes, exactly. I either consult teachers or go and work with the child directly, depending upon the district.
Okay, I see.
May I ask the question?
Yes.
Katie, first of all, thank you very much for your information. I have two questions. First, what is the situation with geometry? And the second one, can you bring some example with algebra from high school? The example which is brightly shows the comparison between the problems of Russian students and others. You brought the examples from primary and middle school. They are rather bright, but also it would be good if you have the example from the high school. Thank you very much.
Well, in fact, what is happening is, I would say that probably the problems in high school, they are stemming from the problems in primary school. And it's mostly the different types of, I will show now the example of what we do.
I see AP
So in terms
calculus.
of geometry, yes, in terms of geometry, it's basically we start with grade 7, like basically, can you see my screen, right? You should be able to.
Yes, I can.
Yes.
Okay. Yes. So basically, when we start with geometry, it's a lot of work. So that's an introduction to geometry. Obviously, there is geometry in primary school. It's mostly very simple. Mostly, we do specific constructions. So we learn how to do perpendicular line, how to do parallel lines, all these kind of things. So then grade 7, that would be grade 7 for up to 9, but that depending on the child. So we will go through this kind of things. So we do angles. There is not that much here. We can see. And the real geometry actually comes into the place in the high school. It's geometry, the year course of geometry. Normally, the children take algebra 1, then they take geometry, then they take algebra 2. And then after that, they do pre-calculus, calculus, depending upon the child. Again, so some of them actually do algebra 1 in grade 7, algebra 2 in grade 8. So still before the high school. So, the idea is before the high school, it's quite a bit of constructions. So we do explanations. Why is that happening? What is, how can you construct? And again, quite a bit of practical questions. Then when we go into the high school, it's also very much practical. I'm just gonna open something else and I will show you the high school textbook. That is honors textbook, and that is we start with logic, then we go into proofs, and for example we do, again, it's a real world problems. For example, using properties of parallelograms, builders use properties of diagonals to square up rectangular shapes, like building frames, playing field boundaries. So how would you lay out a rectangular patio for use centers? So all these kind of things. So we do, at this stage, obviously, we do proofs. And our proofs will look something like that. It's called 2-column proof. So we do statement and we give a reason, which theorem is used, and but I don't think there is there's not that many problems with geometry normally. There are problems, but they're different problems. So they're not connected to the fact that there is a very different approach. I don't think so. It's mostly if the children are just bad at geometry, they're bad at geometry. But otherwise, they just study and they learn it. So the idea is, I think, the same. I think what I found very interesting and about geometry is that in Russian tradition, there is no reflex angle. So there is only angle up to 180 degrees, and anything else is not supposed to happen, or I'm not sure how it works. So that is quite interesting for me, because obviously in English speaking tradition there is a reflex angle between 180 and 360 degrees. But again, it's not a big deal. Children learn it and they know it. That's not a big deal. So I would not say that geometry as such is a problem. Not really. In terms of algebra, high school algebra, yes, the problems mostly stem from the primary school, and that's the deep understanding and the deep maybe how to say that, application of what we need to, how we need to apply what we have. So that's in terms of algebra. We do a lot of projects, we do a lot of work which are based on the basically real life. Again, the fields, calculations, different type of calculations which we use for real life. And sometimes children struggle to interpret the results. And they want to be given the recipes. So what do I do here? They don't want to have the principles, they want to have a recipe. So how do I solve this type of equation? How do I do that?
Yeah, okay. So about geometry, about angles, well, in high school, we definitely in Russia, the angles of arbitrary degrees are studied because of in trigonometry. Yeah, you can substitute anything instead of x when you have cosine of x. Yeah,
Yes.
also at the same time when radians are studied, I think at that point any angle could be used. But
Yes. I just was a part of the discussion. It was interesting, and the Russian math teachers. So I was just quite surprised that they said that no, but there is no such an angle. And they said to me, but what is that? And I give a convex quadrilateral, and they say, but we don't study that at school. So this angle is not really an angle in geometry. Yes, in trigonometry, I know, yes, they use it, but not in geometry, not in the shapes.
Yeah, I think that because in geometry, well, at least in one textbook, the angle is defined as just the set of points that constitute the sides. Yeah, so two rays that have their common starting point, and in this way you have like for any angle you have interior and exterior, and interior is always smaller than 180, and when you have a line, yeah, that is like both could be both sides of it could be treated as interior or in exterior. Yeah.
Yes, I actually found that as well. Yes, and we've discussed it, that the definition of the angle is different because we straight away give it as a space between two rays.
Yes.
With the common vertex, space between two rays. So that is an angle.
Yeah, but so here the whole question: do you have the order? Is this pair of rays is ordered? Yeah, because if it is ordered, of course you can have angles between more than 180 degrees. But if it is an unordered pair, how do you decide from what is the angle? And like the usual way, the way that is use this, so you just define the angle as the smallest, the smallest rotation that you need to perform with one to go to other. Yeah.
Yes, obviously, yes. No, I understand, but again, it's not a problem. It's just something which can easily be explained and told. So it's there is no different approach. That's what I mean. So that's like in that aspect, there is no different approach.
Yeah. So the main problem is the problem with accept new rules. Yeah, so when you when you are
Yes.
when you've studied it one time and you don't want to look slightly from a different angle. Yeah.
Yes. Yes, that can happen. Especially when the teenagers come, they obviously, they sometimes they can be resentful.
Okay, may I ask a question?
Yeah, you're welcome, Tim.
Okay. So first of all, Kathy, thank you for your talk. One question that I had is, could you please clarify about the coordinates? I heard, but I don't quite remember when the polar coordinates are covered in the American school.
Polar coordinates.
Yeah. And the second is more like, yes, so you talked about some problems that Russian or children that have background in like Russian math education, problems that they have switching to the American system, and some of those problems are from my experience, it's kind of similar to what American kids also have. Like I have a student who is American and was born in the United States and have studied in the United States. And when he was in fourth grade, he had the exact same kind of problems that you showed about the remainders and about understanding what they are and about interpreting real life scenarios as mathematical problems about like writing equations or inequalities based on the text task that's given on a real life. So what I wanted to ask is more like you said that there is that the Russian school system usually gives some reasoning and then a rule, like an algorithm, so the student can just use without understanding the underlying method or how it's what's actually happening. But then, in some practical terms, maybe sometimes the algorithm is useful. For example, if let's say with operations with fractions, like adding, subtracting fractions, they can understand how the rule of switch of converting to a different denominator works and so on. But is that strictly like necessary for practical application of actually like adding fractions, or is an algorithm, or can an algorithm be a useful thing as well as an other understanding?
I think the understanding should be first, and if the recipe is done too early, and I'm not talking about the children with special needs. So that's a whole different ballgame, and obviously we are looking into different rules there, and we don't want to cover that at the moment. But I just want to show you how we introduce these fractions, and with the children mostly. And what I wanted to say also about the difference, yes, sometimes algorithms are better. We had a discussion very recently, a couple of days ago, because one of the Russian teachers actually asked, why do we not teach? She has several students from America now at the moment, and she says, why don't you guys teach the quadratics formula? We do teach quadratics formula, but we don't want them to use it that often. So basically what we do is quadratics formula is we want them to solve it in the most efficient way. And that is most of the times is not the most efficient way to solve the quadratic equation. But the argument she was giving was the same. It always works. It's not difficult for children. I think that's not the right module. Okay. It's not difficult for children, and they are ready for it. So why won't you just teach them that and forget about everything else? So to me, it's strange because I always think that we need to really give a full understanding. The children should understand what they're doing. And that is very, very important. So what they do, I actually don't have, unfortunately, is that. So what we do with children, how we introduce it. Here it is. Sure. We want the children to have understanding before they can formulate the shortcut. And for example, what we do here is, I think that's addition.
Yeah, but the cuts, like vertical and horizontal cuts.
Yeah, so that's what we do. 2/5 plus 2/3. So we do, and we spend quite a bit of time on that. So until there is a deep understanding of what is supposed to happen. There is no algorithm up to, most of the children don't need algorithm after that. So they do have an understanding. They figure out the rule themselves. So yeah, that's basically the whole idea of, that's again the principles of that. And yes, the children with special needs, they do need shortcuts, but that's a different ball game. That's different sphere. But the average child, normal child, they are quite able to understand all that. The problem I have with this approach and the children coming from this approach, they're so used to be given them the rules that they don't want to think. And they unfortunately start it themselves. So if you don't give the rule, so the question is, but how I do that? How do I do that? But think about it, make a plan. Here it is, just think and make a plan. No desire, because I want to have a rule. That's it.
Yeah, Alexander, you have something to say, I see.
Yes. One more question, Kathy, please. Do the teachers in USA use GeoGebra often, or it is exception? What do you think about it?
We use a lot of things. There are several very good programs, so it depends. Mostly, I will be very, very frank with you. It depends what your district provide. So district decides what to buy and to subscribe. So we have options of using what the district bought for us. But there is something, yes, either GeoGebra or there are several things. There are several programs which are really good.
But I wanted to know, is the using of this program is usual practice in the schools, or less of the teachers use them? For example,
I wouldn't say that many students, so many people use it. No, not that many. I wouldn't say so. But I can't say it. I can have a look at the statistics, which districts actually buy it. We can have a look and then estimate how many teachers would use it. But it's not really, it's not very popular. Let's put it that way.
It is not very popular because of the complications or because of the absence of the desire of teachers or something else. What do you
No,
think?
because there are just so many options. There are so many options, and you choose what you want.
Mhm.
So yeah, there are really a lot of them. So there are a lot of explorations. At the moment, there is Synergy, which is becoming extremely popular. That's AI-based program, and it's quite impressive. So we'll see how that will be used soon. So that's like the buzz of the day. But yeah, it's all the time there is something new, and there is brilliant, there are so many things.
Thank you. I understand. Thank you.
Mm-hmm.
Yeah, and also about geometry, I think is it right that in United States geometry is more studied and taught in coordinate form, not because in Russia coordinate method or it is like a very it doesn't come at the beginning. So at the beginning we have axioms, something like this, like find equal triangles, a lot of tasks about that. Triangles are
Same thing.
yeah.
Very much same thing. Yeah. So if we look into the textbook, you will see that we start with well, that is the latest textbook, basically, and it's Common Core. So if we look into that, you will see that there is an introduction of tools of geometry. So we look nets and drawings for visualizing points, lines, and planes, basically measurings and basic constructions. And then we go into reasoning and proof. So we go basics of logic, patterns, inductive reasoning, biconditionals, so all these kind of things. And then we go into the parallel perpendicular lines. Then we look into the congruent triangles. So that's what you are saying. Congruency, and then relationships within triangles, and polygons and quadrilaterals. And here we start to apply coordinate geometry. So at this stage. So, and then we introduce the proofs using coordinate geometry. Yes. So when there is a certain base already.
What is the grade at that moment? In what grade?
It's not a grade. It's a course. It's a course of geometry. It comes from after Algebra 1. So, well, average child will take it in grade 9. Some of them will take it in grade 8. Some of them will take it in grade 10. So it depends. Some of them won't take it.
Alex, you remember in our schools in Russia, they begin in the end of the 7th grade. Elements of these elements, the equation of the circle, the line, and so on.
Yeah, probably.
Yes, that we also have, but the equation of the circle is a part of the owner's math. The equation of the circle is introduced in the end of grade 6, I think. There is a big investigation there when we look at locus and all the points equidistant from one point, and then they come up with an idea that that's a circle. And how can we describe it? That's after they know Pythagoras, obviously. Yeah, so that's that. But that is not really. You see, we do a lot of groundwork in the primary school and in the middle school. But then the high school is where it all comes together and is all systematized.
Yeah, I see, and definitely their statistics and probability theory comes at the end of school if it really comes. Because yeah, so I think that when I studied at school, I had no statistics and a little bit of probability theory, like a little bit, really.
Well, as a course, it comes as a part of AP Statistics, which again, the child who is going to like university-bound child, basically, this is a child who will take AP Statistics probably in grade 11, most of them. So, and that will be like stats and probability. But the elements are all the way. All the primary school, all the middle school.
Yeah, I see. Hello, Sergey.
Yeah, I wanted, hello, and thanks for your presentation. I'm sorry I'm without video today. I just wanted to point out that in Russian schools, they're trying to introduce probability and statistics and to extend it. Just theoretically, it has to be like from grades, as far as I remember, from grade 7 to grade 9, whole quarter each year should be dedicated to probability and statistics. So 1/4 of a year during 3 years. And now the plan is to extend the course, and they want to introduce something from graph theory, combinatorics, so some elements of discrete maths. But the problem is that many teachers are, the majority of teachers, in fact, not ready for the course, and they cannot teach it properly since they don't know it themselves, and that is what represents the major problem. And one more thing that I personally think is about the approach you underlined several times, that in Russian schools the students, they seem to be towards rules, like there are several steps, the first step, the second step, and so in order to add the fractions, you need to find the common denominator and so on. And why do it this way? Yeah, the majority of children cannot explain. And the matter is that maybe also the textbook, if you just read through it and look at it, even in any ordinary textbook that was used in school during Soviet times, and nowadays they're quite similar. And so it provides good explanations and good examples, but maybe teachers are trying to prepare children for tests and just don't make good accents, and they only care that their students are successful at some tests, maybe state exams, and that's the major point of their work. So not to explain why something happens, but just to provide the algorithm so that the students can solve the tasks afterwards. And there are teachers I know who teach in quite a different way, and I myself, I was lucky to have a good teacher, and I didn't experience anything of the sort. But yeah, unfortunately, I know that mostly it is the case nowadays that algorithms are taught instead. And as for one more point that I recall now, as for using calculators, I know that there are some attempts that are being made to make calculators legal at school and at the state exam that happens after the 9th grade. As far as I know, the calculators were legalized, so the students were allowed to use them. It hasn't reached the Russian state exam after the 11th grade, so after the graduation, that happens just after the graduation. But some discussions were being made, and the decision was negative, so the calculators were not allowed yet. But maybe some steps are being done on that way. And one more point. It's just refers to the very beginning of your talk about some problem with a ferry boat, as far as I remember. Maybe I'm just curious if you try to give it a little bit different formulation. So the question in itself is it's maybe quite baffling to a child who is not used to getting such questions at all. So it was something 30 something cars, and the ferry boat which can carry that's it. A ferry boat which can carry 8 cars at a time. So I'm just curious if you ask such a child. So assume that a ferry boat goes from one bank of the river to another bank only if it is fully loaded. So how many cars will be left waiting on one side? I'm just curious if the child is able to answer such a question. For interpreting the results of the division is, frankly speaking, something I've never seen in Russian textbooks. So it's usually find something. It can be practically formulated, but the meaning is that you have some question and you have to figure out the answer to this question, but it is not formulated in such a way. Yeah.
Well, it's different pathways. So basically what we want to do, it should work both ways. Yes, she should be answering one question and interpreting the results of the division as well, because that all should be synthesized in the brain. But of course, it's not, they do it a lot, obviously. When we do division, it's all the time interpretation, and the children still struggle. In the classroom, some of the kids who are there from grade 1, from kindergarten even, maybe, so they actually say that, that's the best part, that's the easiest part, okay, to explain what is happening. But yes, on the other side, the other children, they can, some Russian kids, they actually can divide, but they cannot explain why. So that is what is happening there and what did they get. So that is concerning, and of course we want to explain and to make sure that there is an explanation what is happening. But in terms of calculators, to me it's very strange, because again, for example, how can you do trigonometry without calculator? So are you using the tables? Or if you need to find the angle based on the sine or cosine, or so if you need to do arc sine, arc cos. So how do you do that? If you have a several step problem, what are you going to do further on? So how will you?
You just leave it as it is. So for example, if you get an angle, or you have an angle that is equal to, say, 50 degrees, and hypotenuse of a triangle, and you have to find the adjacent leg, you just write the answer as, for example, 10 multiplied by cosine of 50 degrees, and that's it. And so you leave the cosine of 50 degrees in the answer, and you're not required to find its numerical value using the calculator. On the other hand, if it is some kind of arc cosine or it could happen when solving a geometrical problem that you have an angle that is, for example, equal to an arc cosine of 3/5. And there is an angle bisector drawn, and so you need to find the sine of half an angle. Then you do it using trigonometric formulae, and you compute the sine of the half of the angle in order to use it further on, but you are not allowed using the calculator this way. And furthermore, any approximations are prohibited. So if it is not stated in the formulation of the task, so using an approximation is considered to be wrong. So you need to get the exact result. So that's the approach that is used.
Well, to me, it actually limits the real life problems. Again, if we talk about the real life problem, we need, for example, to find the angle, and then based on the angle to find something else. That's already a problem. And then to analyze the result. For example, the bearings when the ship moves in the sea or the plane is moving in the air, right? So all these kind of things. And that obviously limits all this, that rules out basically all these kind of problems.
Yeah, I got it. And I agree that, in fact, it is something that's lacking in Russian school program, that there are too few practical problems, and specifically, when you solve a practical problem, so you might need to find the cosine of 1/3 of an angle, and that's impossible to do without a calculator. And of course, so here you're completely right. But so it doesn't exclude the possibility to work with arc sines and arc cosines and with trigonometry altogether. But there is a distinct limitation on practical problems.
And the same with the statistics, because any real-time statistics, it's huge numbers, which are, I don't know how long you will calculate it. I know that NASA ladies, actually, they were calculating by hand all the, they made calculations for the satellite, but nevertheless, we are not at this stage already, and there was a whole, I think 50 or 60 of them. So nowadays, we actually want to use, I think it makes sense to use the technology where it's appropriate.
Yeah, by the way, as for statistics, I've seen that, for example, if we take IB tests, so I've looked through the book, and they recommend using scientific calculator that may find a lot, that can find a lot of different things. And for me, it seems kind of weird. So you have to get used to how this specific calculator works. And after that, you just enter the numbers, and the calculator gives you all possible values like mean value, standard deviation, variance. Maybe if it is a two-parametric data set, it gives you correlation coefficient. And so all you need is to know how to enter the data into the calculator, and you get the result. And for me, such problems, such tasks, they seem kind of pointless, so I don't understand why they're necessary. So there are some of the tasks that are practically oriented and quite useful, but there are some others where you need to master the calculator, which which you will never need in real life. For those people who really work with data analysis, they're going rather to use Excel or some other computer programs, but not calculators.
Yeah, I don't know about that. It's just, I think it's basically to make sure that there is more interpretation than calculation. Well, the process of calculation is the same all the time. So there is, for example, one task to calculate by hand, and then everything else is interpretation, where you can use calculator.
If I may jump in for a second,
Mm-hmm.
you hear me?
Yeah, of course,
Yes.
of course,
Yeah.
Sergey. Oh.
Yeah, sorry. Yeah, sorry, I was late, so I don't want to go into something that might have been mentioned during the presentation, but just to respond to the last comment. Well, having also experienced teaching both in Russia and in the United States, I must say that it's a very interesting point, because it all on the one hand, you're right. On the one hand, what are we teaching if they don't know how to do all these calculations for standard deviation, all that stuff? On the other hand, I think the approach here is a little bit different. The approach is, okay, we can spend half an hour just calculating standard deviation, and you can show that you know how to calculate it, even though I claim that most of the students, if you give real data, not the made up data with good numbers, will make mistakes in calculating it manually. Not only kids, but most of the people will make mistakes because the numbers are crazy, right? The idea here is that you can't, if you just press buttons on the calculator, as you say, it's not enough, because you need to understand when and where to use what. So if you don't have any understanding of what mean or standard deviation is, just pressing buttons on calculator will not, I mean, it will be helpful to calculate it, but that will be the end. And the problems most of the times asks for some, as Kathy said, for some interpretation. And if you don't know what they are, you won't be able to interpret it. So I think we should try to clearly understand the difference. And that's, I think, one of the most interesting distinctions between Russian curriculum and American curriculum. And I think none of them does perfect job, but at least, they try. Here, the thing is that we talk about, okay, what is more important? The amount of calculations we have time to do, or the amount of interpretations we have time to do. And I have my answer, but I don't impose it on anyone. Interpretation is more important. And also, another interesting thing that I, again, don't know if it was mentioned or not. If it was, please stop me. I don't want to repeat, of course. But when you say calculators in Russian curriculum, it's kind of interesting, because on the one hand, yes, no one, I spoke with kids even from specialized math schools. They have no idea what a scientific calculator is, not even to mention a graphing calculator. That's almost like an alien from a different planet to them. But at the same time, a lot of schools and a lot of teachers, not everyone, but quite a lot, use software like GeoGebra, they use GeoGebra, they use Desmos, some use Geometry Sketchpad, but much less. So it's interesting that they do use technology, but calculator is almost unknown to them. And sometimes, I see calculator as something that saves you time, because, for example, and that's, to me, that was one of the, I would say, enlightening moments when I started teaching in the States. That, for example, you teach transformation of graphs. And in order to show how graphs move when you change the X component, Y component, if you multiply by a coefficient here, multiplied by a coefficient there, in Russia, it takes you several lessons at least, because every graph you do, you have to manually graph. And if you, okay, we add 2 to x, oh, let's manually graph it and see that it moves 2 units to the left. Let's, now subtract 3 from y, and let's manually graph it, see that it moves down 3 units. Okay, it's important to be able to sketch graphs manually, but again, to what extent? Here in the States, I can teach transformation of graphs basically in 2 lessons because I visualize it and I say, okay, let's look what happens with the graph. And I immediately can do it. Okay, let's do it with x squared. Now let's do it with sine x. Now let's do it with natural logarithm. And you see that the transformations are the same, no matter what the graph, what the function is. If you add 2 to x, it always moves 2 to the left. If you subtract 3 from y, it always moves down 3. And to me, this is much more efficient in terms of learning rather than being able to sketch every graph manually and basically take forever to explain all the transformations. Not to say that, for example, here with the calculator, it's very easy for me to also do transformations like absolute value of the graph, of the function, or absolute value of x, or much more complicated transformations that in standard curriculum in Russia are done only in specialized schools. So I think it's a matter of the wisdom of using calculators, not the use of calculators themselves.
Yeah, and if I may comment a little bit on calculators and arc cosines and stuff like that, the trigonometry that was talked about. So I also think that using a calculator to find the specific values of the angles, for example, is important to actually understand better what arc cosine and cosine are, how they work, because a lot of Russian kids, from my experience, have the same kind of problem where they kind of mix up what these functions represent and what the arguments for them are. That the fact that the argument of a cosine is an angle, and the argument of an arc cosine is a number, is a ratio, and they mix these up because they don't. Because for them it's just like some kind of number game without any meaning behind it. And also, this kind of things like calculating angles with the calculator, they are included in the physics course in Russia, and the physics course is compulsory in Russia. So I suppose maybe the idea was that students would learn that in the physics course, but it doesn't really work because a lot of students don't see physics as a very important subject, and even those that do, they still kind of struggle with that. So yeah.
Okay, so if and by the way, maybe we'll return one more time to this problem about ferry and cars. Our best friend. Yeah, because I wanted to concentrate on it because specifically the question how to interpret that we can't divide without remainder. Yes, it seems like okay. That means that okay, maybe it's easy to say what it means. That I can say well it means that the last trip will have not on the last trip the ferry will be not fully loaded. Yes, and the question what does the remainder mean? I don't know. It seems like a little bit tricky. For me personally, I mean, I want to reconstruct what problems did Russian students have, and for me, it seems like you don't know where to start. It's like, okay, so it doesn't give you any particular idea what's happening. Like when I try to reconstruct the situation, I think about a lot of factors. So you can think about it from a lot of angles of view. So it's like not clear where to start for me. Yeah, maybe I would have this problem.
Yes, but that's partially because you don't have the framework, because you were not taught in that way, right?
There are two key issues here. So what is the best way to interpret the remainder so that all the cars can cross the harbor? So yes, if not all the cars cross the harbor, then the remainder will mean that there are 5 cars left behind. So if they all cross the harbor, then the last ferry won't be full. So it has 3 empty spaces. So yes, that's basically the question.
Yeah, okay, but this is really something that in Russian schools it is not asked at all. Where you don't really like when it's not formulated, like you need to give some clear answer, but you need to describe the situation in your own words. It's I think it's never done in math classes in Russia. Yeah,
I think so too. I haven't met a child yet who was comfortable with these questions, who was coming from Russia and was comfortable with these questions, or who was aware that is even a possibility.
I can tell you a story. I like to take the first grade. It is we have in Russia 4 grades primary school, and it is like a middle, so not like the first 6 grades are primary, but the first 4, and then they are going to the elder level. Yes, and I like to take the 5th grade because I don't need to fix them at 8 or 9 grade. And one day I was so angry about this situation because they try usually, they have like one way distant only to move for question. And when the problem become more difficult than in the primary school, like in the more difficult than in the 2nd grade, maybe, and there are more there are more data in this problem, they try to to do something with numbers they don't understand. And one day I said, okay, now we will have problems without questions. So yes. And maybe after 2 months of such work, they tried to think about it, because really you showed us the textbook of the primary, it is Peterson. Parents in Russia thinks that it is the better, the most strong textbook, and I can say that my experience says that after this textbook, children can do more and more algorithms, rules, but they can't think. I think it is my opinion. Maybe not all people think the same, but I hate this textbook because children say that it is strong textbook. They are very, very clever. They are the best because they learned by this the best textbook. But when you say that they don't understand the problem, they hate me, of course. So that you need to think, that you need to find the objects or the personals or about what in problem, about what we are thinking in this problem, what we need to count, what this number, about what object, and they really don't have this practice, really. I think it is a very sad situation, but I don't really have no ideas about now what in Russia we can to do with this. Maybe they need a lot of time, maybe to repair this if they want. I don't have no idea about it.
I can tell you there was one line of textbooks in Russia authored by Bashmakov, I don't know if you've seen it or not. And that's a line of textbooks that actually was written from grade 1 through high school. In my opinion, that was the only line of textbooks that actually tried to present the approach that you're talking about, because Professor Bashmakov, who wrote them, he was like one of the deepest, probably, mathematicians and math educators of the late 20th century, and he included history of math in his textbooks. He included all this kind of thinking problems, etc., etc. And guess what happened? His textbook was almost rejected by most of the teachers. It was officially published. It went into the official list of textbooks by the most influential Prosvещение publishing house. But
Almost in procession, yes.
most of the teachers rejected the textbook. And I still sometimes talk to teachers who say, oh, that textbook was so like ridiculous, so difficult. Yes, of course it was difficult because you can't follow algorithms. You have to think in this textbook. But
yes. I think I'm sorry. I think that most of parents who come to the teachers are not don't know what the math is. They don't know math at all. And I'm from the region, not from Moscow, from the Far East, so very, very far region from the Moscow, from the central part of Russia. So I can say that really most teachers don't know math and can't teach math. It is a tragedy and the problem of Russia. I understand about what you are. Yes, I know this textbook, and I know that the good textbooks are not in Russian schools yet. Yes.
And to amuse you all, speaking of the Patterson's textbook, there are a lot of discussions about this book, and 99% of the times you will read the discussions and you will see the author being referred to as he, him, his book, he knows, he does not, and people don't even know this is a woman. Patterson is a woman, actually. That's how like little people really know about the curriculum they talk about.
Thank you. I think that like people in Russia, and maybe, I don't know, maybe in all the world, doesn't think about this. They call this name like it is like a subject, like this subject. Like this is a textbooks of Patterson. They don't think that it is a person who has the history, who is living with us in this real life. So, yeah, that is interesting comment.
I find and actually that's a global problem, I think. The relationship between children and math are sometimes very complicated. And somehow we came to the culture when children expect that they can solve any problem, and they are expected to solve any problem within a certain amount of time. And when I talk to my kids, who kids I teach, I try to explain to them that some mathematicians worked on the math problems for decades, for basically for 50 years, for 60 years. Some of them never solved them. And the process is also important. But this understanding is not there. And this, I think it's obviously because of the test, the standardized test, the state tests, everything which we need to do, which children want to succeed. And the parents obviously also want to succeed. But then they come to the point where if they can't solve it, they are crying. And I'm talking now about the very specific Russian children, but that's not specifically this problem. I think a lot of other kids also have it. I tutored a girl who is of Russian background, very clever, extremely clever. English is not there yet. And we were supporting her. And she wanted to do Math Olympiad, which is great. Like a Kangaroo Olympiad is a great thing. So basically, and I gave her the past paper and she couldn't solve the problem. She started to cry. And here, that's the response of the child who already doesn't have right relationship with math. And unfortunately, there are a lot of kids like that.
And maybe I also can add a little bit that maybe to the other side of the discussion, that maybe at least some of the problems that Russian children encounter while entering US, maybe US children would have similar problems if they go to Russian, because some of the problems may be not specific to your background, but to the fact how do you adapt to the shift in the way of teaching. Yes, so just a general thing about like stress after moving to the new place, after seeing a new approach. It could also be some part of some problems. Yeah.
But of course, because we have kids who do attestatsiy in Russia to keep going.
Yeah.
And they are struggling also there now because they don't know how to write it properly. So, and Russian math is so much about how you write it down, what you write where, what do you, which number is where. So, I mean, the tests. So yes, obviously it's very complicated also to adapt to any kind of new situation, different situation.
Alex, I would agree with you if I knew so many situations when the students from USA came to Russian schools, but usually we talk about another side. Usually we need to adopt I don't know, Russian children to the world schools.
To support Alex's idea that things actually work both ways, I don't know which direction is more streamed. I mean, no, it's obviously which the one, but I want to support the idea that both directions exist. I remember when I started teaching in the US, one of the first experiences I had, and I actually was puzzled by, that it was very hard for my American students to start thinking about negative numbers. We just spend a lot of time trying to understand how it works, what they are, how to operate with them. And I was puzzled because honestly, this is one of the things that at least I did not experience a lot of troubles with teaching to the Russian kids. And actually, I got my hypothesis. You may totally disagree with that because it's just my hypothesis. But at some point, I realized what happens in my view. I recalled that when I was a child in Russian school, as probably all of you, I did in the elementary school, when we started talking about negative numbers, what did we have to use? What did we have to make by ourselves or get in the store?
Low temperature, below zero. Yes, of course. Yes.
About temperatures.
They don't know what is the temperature
thermometer.
below 25 degrees, below zero. Yes.
And in the US, they use Fahrenheit, or we use Fahrenheit. It's very rare, especially below certain area. Okay, somewhere in the north, maybe, but like New York and lower, they barely see negative temperatures in life. That's why they do not have any real life connections. And it only proves, once again, no matter where we are, in which part of the world, that when we have real life connections, things go much easier and much more efficiently. Because they don't see negative temperatures. And someone told me, oh, but they can think about money. Come on. Kids of 7 years old, they don't think yet about money in terms of I owe or I don't owe. It may work for older kids, but for the young kids, temperature, and there's no negative temperatures. That was so interesting to me when I thought of that.
We normally introduce it for the very small children as the basically holes and the sand, when you do the sand castle and the hole. So there are the holes and the sand castle. So the negative one is a hole and the positive one is a sand castle.
But a thermometer is such a good analog because it already has the actual negative numbers, so the kids get used to it from the very early age.
Okay. Any other comments? Yeah. It's we are already here for almost 2 hours. Yeah. I think it was, for me, it was a very interesting experience listening to the perspective of a tutor from States about Russian children coming into States. Yeah, seeing it from a different point of view. Thank you, thank you, Katie, for your talk.
It was a pleasure.
Okay, so well, next time, next Saturday, oh no, next Sunday, I hope Sergey will give a talk. Yes.
Well, it won't be really a talk. If we
yeah.
do what we plan to do, it won't be really a talk. We wanted to, and it was also coming from the requests. We would like to continue talking about international programs, but from the perspective of looking at some particular tests. So we wanted to talk about the formats, the real formats of the tests, and then we discussed with Alec that maybe like one time we'll talk about formats and general requirements, and then one after that we can. At that meeting next week we can distribute electronically, of course, some sample tests, and then next time we can discuss some particular problems that people may find interesting, if it makes sense, of course.
Yeah.
Sergey, is it possible to send some examples of those tests about which we will discuss on this meeting? Maybe it will be useful to have a look at them a few days before the meeting. Is it possible?
We can, yes, I can try to do that. But as I said, the idea was that first time we look, we browse through them in terms of format. And then for the next time, everyone has the tests at their disposal. And then we can next time discuss more particular examples. But I can still send some samples. Yeah.
Taking the opportunity, I would like to say a lot of thanks to you for those textbooks for IB maths, which you sent in the group. It is very useful indeed. Thank you.
Thank you. Yes, I hope it was useful. And also, someone sent even like more broad link to even non-math IB books, so that was also very useful. Not only IB, by the way, there were like a lot of other interesting sources there.
Okay, and by the way, what do you think about the time of our meetings? Yeah, we have a lot of possibilities, like this time or 1 p.m. Moscow time.
I mean, if you ask me, for me, the later it is by Moscow time, the better, because you always have to subtract 8 hours. Mm-hmm. So, but yeah, like it's up to you to decide.
I have 9 hours with Moscow, so it is very early for me, and I have 11 months child, so I don't sleep at night. If it will be later, it will be more comfortable. Yes.
Okay, so maybe we can meet at that time, 8:30 Moscow time. Yeah. Okay.
No, I'm not sure that I'll be able to be present every time. It's too late for me, but yeah, if I'm able to come, then I'm going to come. But okay.
And where are you? Sorry.
So now it is 2:30 in the morning. Yeah, so little bit too late, but the talk was interesting. But if we start 8:30 Moscow time, it would probably be okay. 8:30 p.m.
It was like today we started 10:30.
Today we started 10:30, and it was a little bit too late for me. Yeah.
Yeah, so I think that I'll make some poll because some participants, each participant has his own preferable time. Yeah. Okay.
8:30 works for me perfectly if it works for everyone else. So 8:30 is good. Yeah, I would even prefer 8:30 than 10:30 because 10:30 is already in the middle of the day.
Yes.
But anyway,
in the morning it is better for me too because I have some deals in the afternoon. So maybe from 5 p.m., 6 p.m. and later by Moscow time, it's good.
Yeah.
Okay.
Agree. But yeah, you definitely can make a poll, and I will try to adjust, of course, but.
Yeah. Okay. So yeah. Good evening, Dmitry.
Hi.
Okay, so let's put it like this. So we meet next Sunday. Yeah, the time will be specified after a poll. Yeah, and I will be glad to see you again. And thank you, Katie, again for your beautiful talk.
It's a pleasure. Goodbye, everybody.
Goodbye.
Yeah, thanks a lot.
Thank you too much.
Bye.
Thank you to everybody. Bye.